Hello and welcome back to Gearhead Geeks, where in this video we are going to go on ahead and talk about how a magneto point ignition works. We're going to understand the theory of it a little bit. We'll look at it in actual ignition and so you understand how it works. Most of the little bikes from 1965 all the way through, I don't know, 75, if they had points, they had a magneto ignition, which means you had an ignition system that did not require a battery. It also, at least to run the engine, it needed a battery for lights and everything else, but that's a whole other story. This is just about the magneto part of it. So with that being said, we'll go on ahead and we're going to look at an actual magneto ignition. We'll draw out how it looks in the schematic and explain how it works. We're not going to go into the electronics part of it. That's not what this is about. It's just so you understand that a magneto ignition system works differently than a regular battery ignition system. So we'll talk about that. So we'll get down to it. We can go look at it, and then we'll come back and we'll talk about some of the different types of things that happen in a magneto ignition system. So, to understand how a magneto point system works in these older bikes, this type of magneto came in many different brands. A lot of these were made by different manufacturers, but they all basically do the same thing. And this particular is a 71, but these things date back probably to the early 60s. So this particular one is off a little Yamaha Mini Enduro, but the point of the whole idea between a mag point system is so that you don't have to have a battery to run it. And if we look up in here, there's only one wire coming out of this. There's no other power. There's no battery. This thing never had a battery. So how does this work? So what we'll do is we'll pull it apart. We'll look at the components, and we'll probably have to do a little cleaning and whatnot in there. But we'll look at the components and explain what it does and why it works differently than a regular point system in your car or one that requires a battery. So the first thing you need to do in all of this is you need to get it off. So in all these Japanese bikes that use this type, they all use the same basic puller. So first thing you do is you get rid of the nut. I got that off of there. And we need to see if we can get these washers out of here. And this one is kind of nasty and rusty, but we'll get all that cleaned up later. And I think let's see if we can get this off of here. Let me go get a magnet. We'll take a magnet and see if we can get in there. Yeah, we got it. It's coming. Just enough magnetism. You just kind of wind it off the best you can. Okay. And we'll do this one. And this one should be the right one, I believe. And you can get these in the kits. There's all sorts of kits out there that you can get that have all the different pullers in it. And they work great. Okay, so that's that. It's in there. And we'll just give this thing a spin. And it pops right out. Okay, so inside here, this is really dirty too, so we're going to have to clean that up. There's going to be a Woodruff key that indexes this guy. So now, let's take a look inside here. This particular one has got basically one coil. And this is the ignition coil. And what it does, well, here's the ignition coil that the magnets pass by and charge up. And then we have, this is just blank. This is a placeholder for a charging coil, because there is a version of the JT1 which has a battery and tail lights and lights. So this is just an empty blank holder. In here we have points. Okay, and a little hard to see, but there's a set of points in here, and they're just like any other points. I can feel these are really sticky and bad shape, and this whole thing needs cleaning. We'll get this all cleaned up and nice in here. And then there's a regular condenser, and we have one wire going to the points and another wire going on out. So these all hook together. There's the wire that comes off of this goes to the condenser, which in turn hooks to the points, which also comes out. And what ends up happening here is, in conjunction with all of that, you can then create some energy, and we'll explain that in detail as we go along. But one of the things to note is there's no timing adjustment. This plate is got one position only. It's got two countersunk screws. You cannot turn this plate. There's nothing back in here to turn. The only thing that you can adjust the timing with is the gap on the points. And that many people don't understand that when you change that gap, it changes the timing dramatically. They say, oh yeah, just have 15 thousandths or whatever it's going to be in a regular point ignition, and then you can set the timing later. Like in your car, you would set the points at whatever, and then you can turn and get the timing. In this one, there is zero movement for timing. The only way you can do that is to change the gap on the points. Now, they give you a specification in the book, but that's basically to tell you how much cam wear you have going on here. That's really all it is. If the things are so worn out that it doesn't move and you can't get it timed, well, that's an issue. So what happens here is, the way this works is this has permanent magnets in it. And it uses those magnets to energize this coil. So if we look and we see that the edges of the coil, and I put a little red mark here and one here, and we've got what we'll do here is we'll stick this back on real quick, and we'll get it indexed properly. It's indexed properly, and there's a little timing mark right there. Okay, and there's a little bendable tang right there that you bend this back and forth. Once you decide where the piston is, how many millimeters before top dead center, you line these two up for future reference. But for the sake of this conversation, we have we're just going to use this reference mark. It's close enough for what we're going to do to see how things work. We're not setting the timing yet. We're just seeing how things work. So, with that being said, our timing mark is right about there. And what we're going to do here is we're going to grab a marker and we're going to look at the magnets. What we have is, we're going to take this and line this guy back up, and he's lined up. So what ends up happening, there's so much magnetism in this thing. Well, let's get this thing lined up here again. It's not. There we go. All right, so that's lined up. And there's that. So what happens here, as this engine comes forward, this magnet right here starts to energize this coil. And it gets to, and it has it's getting as much energy as possible into that coil, and then it's just about where this magnet is lined up perfectly on the edge of this the coil inside. This magnet sits here, that coil goes from here to here, and there's a little bit of whatever, but this magnet is right dead smack at the end. So it has put as much energy into that coil as it possibly can, and at that particular point in time, the points break. Boom. So what ends up happening at that point is it goes through all that energy, which has been grounded out, and we'll go through a better explanation of it. The points have been closed so that both sides of that coil are completely grounded out. There's a bunch of energy stored, but it's got no place to go. It's just there's ground. There's no place for it to go. As soon as these points break, all that energy stored up in that coil wants to go out somewhere. And what it does, it goes out this wire and into the coil, and boom, you get a spark. So we'll explain that a little bit better. But this relationship right here, this guy right here, the beginning of this magnet right there is right over the top of that coil, and it is got all the energy in it that it can possibly have. And once it has all that energy, it stores it, and as soon as the points break, boom, it pops it out and it sends up a pulse. So let's explain how this point magneto system works by, first of all, pointing out the component, and then we'll draw it here in schematic form, so at least you have a better understanding of what the components are and what they look like. To start with, we have this coil here, and it is wrapped around a ferrite metal core. And this metal core allows magnetism and to work in the way that it needs to generate electricity. And it's relatively simple. First of all, we have a windings around this core, and the end of that winding is now grounded. And the way we look at ground, the way we'll draw ground, is this little arrow pointing down. Then up here, excuse me, so that's this guy here. One side is grounded, and the other side is actually going to go off to our points. And the way the points are going to be drawn here is we're just going to draw, got a little device here, and then we're just going to draw one side of the contact here, which goes there, and then the other side of the contact does nothing more than go to ground. All right. Then on top of that, this has the condenser, capacitor, condenser, whatever you want to call it, and it goes to ground. All right. And this guy here is this guy here. This winding is here. That's this. And our points are right here. And that is basically what we have inside this whole area here. And there's going to be a magnet spinning around in here on our flywheel. And there's 4 magnets inside here. But the next thing we have is our coil. And this differs from other types of coils that you would see in a car or in a normal system where you have a 12-volt battery and you turn on the key and you have to have a key to start it. Well, turn on the key, you have to have power to start it. Your battery has to be charged, yada, yada. But we don't need that. We need no power. There's no battery in the system at all. So what this is there's what's called the primary winding inside that coil. And it's just got a relatively small number of turns in it, and it's fairly heavy wire, and it's grounded, and it grounds right to the frame. That's just what one side of it does. The other side of this goes directly to this system. That's the wire coming off with a little connector in it here, right here. And then there's a secondary side, which is also grounded internally, and it's got a ton of windings in it. That's what's going to give you the spark that you need. Okay, and then it goes off to a spark plug, and our spark plug kind of looks this way, and there's going to be a bolt on it, and then there's going to be the electrode comes right through the middle of it, and then there's going to be the electrode that comes this way, and this is grounded via the threads. So this is our ignition coil. This is the igniter coil, whatever you want to call that. And this is the entire circuit in there. And the way this works, it's relatively simple. In the world of a regular, and I'll draw this over here, in a regular coil, you have a primary winding, just like we have up there, except innate goes to a set of points, just like in ours, except this side of the coil goes to 12 volts. And what ends up happening is when this, then we also have another set of windings in here, and that goes off to our spark plug. Actually goes this way, and then it goes off to our spark plug. And what ends up happening is this coil here, once this grounds, it builds a field, a magnetic field. And what ends up happening is the points break, so the points are closed. It's building up a magnetic field because there's 12 volts here, there's 0 volts here. You build up the magnetic field, and then what happens is the points break, and this field collapses, causing a spark to come across here, and this goes out to our plug. And that's used because you got 12 volts going in, and you're creating a field and then collapsing it. Creating a field, collapsing it, creating a field, collapsing it, and then you get spark going out. Well, we are a little different. We don't have that. We don't have 12 volts. We got nothing. So what ends up happening is this one, it's a little bit different. We have a magnet, and actually there's 4 magnets inside this flywheel, and they are rotating around in here, and 3 of them will go by, and they're putting a little bit of energy into this coil. That's just the way electromagnetism works. We're not going to go into that explanation, but basically you wave a magnet by a coil, and with this ferrite center on it, you create a really strong field of electricity. The problem is with this is these points are closed, and they are touching here, and so this side is grounded and this side is grounded. So even though the magnet's going by, it's building up in this, but there's no place for that electricity to go. It's just ground. Both sides of this potential are completely grounded. There's no place for it to go, so it's just building up energy. Well, what ends up happening here is that one magnet finally comes around, and they're kind of curve shaped, and they're in a perfect position to be right over the top of that coil. Actually, it's a little further down, but that's okay. It's right about there, and it's covering this whole area right here, and it's just got a big field going off in there, and our points break. Our cam goes off, and our points open up. And once those points open up, this has a place to go. So all that stored up energy goes up in here to our primary winding on our coil, and with that field expanding so quickly because that energy is so stored up, it then creates a spark out to our spark plug. And that is the end of it. And also, once that spark is done, then these points close again, and it gets ready to charge up again. There's also another wire coming off of this that we would have, and we can just tap into anywhere in here, and this would go to a kill switch. So even at the pointer opening and closing over here, if we have this kill switch down, this coil is just grounds out through the kill switch, and that's all that it does. And this just happens over and over again, and that's how it works. So it's opposite. It is an expanding field that gets these to work. There is only one wire other than the plug wire going to this guy. There's no 12 volts going in or no 6 volts going in. It's just, this is grounded, and you have just this energy going through, and that's the end of it. It's very, very straightforward. You just have to understand it's just the opposite of a collapsing field. It's an expanding field. And that's the way a coil is nothing more than a transformer, and it works with AC current. So it goes high and you get an energy and it transforms it, and then it goes low and it gets energy and it transforms it, so that waveform, which is AC, and this is positive and negative, and each time this changes, when this goes up and then it collapses to zero, it then can charge either side of a coil. I'm not going to go into how transformers work, but that's just the way they do work. So just to understand that this is all that you need to have a magneto point system. These little points go off here, they open up, they discharge through the coil, you get a spark. That is the end of it, and that is the way these work. So the next thing we need to understand about our little ignition here is timing. These particular bikes don't time in the same way that a conventional point system works with the battery and 12 volts. If you look, this timing plate right here has got, well, there is no adjustment whatsoever on this. You cannot turn this plate. It is in place, and that is the end of it. There is no, let me put a screw in here. There's no place at all for this to turn. There's no backing plate in here that you can turn or do anything else to adjust the timing. So how do you adjust the timing on these? Well, because of the fact that it doesn't need the dwell time of other things, you adjust the timing by opening and closing the points. And what happens here is there's a cam inside here, and it opens and closes the points, and the point gap is not really anything to worry about. The only reason they even talk about a point gap is to see if this cam is worn out or if your points are worn out and it can't open it enough. So basically what it does is you, in any point system, adjusting the points changes the timing, and it changes it dramatically. So you always have to remember, oh yeah, I've got a regular point system, I'll just set the points and the timing will be okay. No, that's not the truth. In the regular point system, you change the points, you have to adjust the timing. In here, what we're going to do is we're going to do nothing more than change the points to establish our timing. So with the flywheel on here, get this in place, how do we do that though? So there's a timing mark on this little guy here, and he is right here. It's probably hard to pick up on the camera, but there's a little pin inside here, but that's a bendable pin, and if somebody has bent it, you really don't know. So what we have to do here is we have to measure the piston before top dead center, and the way to do that is with a dial indicator. Now I happen to have one of these dial indicators. I'm going to move it over so we can see the cylinder head a little bit better. And the way this works is there is a pin that goes in, and this will go into the cylinder, and we can go on ahead and it will measure how far the piston goes up and down. We can find top dead center by when the piston comes up and then it starts to go down. We'll see that point where it does that. This is a genuine Yamaha dial indicator from this era. It is designed specifically for this kind of bike. So you just thread this guy in, and you got to get it started. I'm in a little strange angle here. Actually, let me just pull this out. thread this guy in, and it just threads into where the spark plug was. Maybe. There we go. We got it. Okay, so it's threaded in. All right, and then all that we do here is we're going to go in, and we should be close because we're close to our timing mark, but we know that all I have to do is, now watch this dial indicator if you can see it. It's coming up, and it's coming up, and it's coming up, and see where it stopped? Right there. It comes up, stops, and then goes the other direction. So that is top dead center right there. So all that we need to do is turn this guy. We're going to make a little bit of an adjustment here. We're going to just move this down to here and right about there. Okay, so we'll adjust our top dead center mark. Okay, there's our top dead center. Okay, and the timing on this particular bike is 1.8 millimeters before top dead center. Ask me how I know. Well, I've done so many of them. It is what it is. So we're at top dead center. We're going to roll this back 1.8 millimeters. There's one, and then here is 1, 2, 3, 4, 5, 6, 7, 8. Well, it's right there when it's on the 20. And what's happening here is the magnet's so strong in here that it's not allowing me to, it's not just stable at the moment. So I'm going to move the camera a little bit so I can get in there and look. And there's, like I said before, there's a little tang in here, and that tang allows you to put it on the timing mark, and then you can bend that tang to where it belongs. And we're going to bend it to where it belongs so that right at 1.8 millimeters, it aligns with that timing mark. And so we don't have to use the dial indicator anymore to get it right. And there it is, and it's just right there at 1.8. So that this little tang is bent properly at 1.8 millimeters, and we don't have to worry about having a dial indicator each time. Now we know that we can do whatever we need to do and just line up that mark, and we're good. Two strokes generally are not that, they don't, timing doesn't need to be that precise. Timing is a very strange thing on a two-stroke. A four-stroke engine likes to have advance, and you've all heard of advance, and we know what that is. Advancing the timing, that means you more and more before top dead center. So as the gases compress, they can compress and they start to ignite, and as soon as it starts to roll over, they get a good ignition on it, and that's the way a four-stroke likes to work. Two strokes are very, very different. They need timing to be very, very close to top dead center, in this case 1.8, and it doesn't matter what RPM, it really doesn't like to have any advance. The more you advance it, you actually lose horsepower because it's not firing at the right time. So in essence, really to make the most horsepower is it actually needs to retard a little bit, but it's not so much that it's worthwhile to do, because that would require a fairly big mechanism in there to retard the timing. So you just set it at 1.8. It likes it. It'll start okay, especially if you're using a Kickstarter. If you're using an electric starter, well, it gets a little bit different. They have an advancer unit in there, and so it'll retard the timing a little more, so it's much easier to start. But then it just advances as soon as it idles, and that's all it advances. It's just a little tiny bit. It just makes it easier to start. So in this particular instance, the only thing that we needed to do is just go on ahead. We now took our dial indicator. We got our mark all set up. We got a little mark on the flywheel here, and we got a little tang bent just exactly where it needs to be, so that we know that once we hook up a device to look at see when the point's open, we can then know that we have got good timing. So now I'm going to use another old-fashioned tool here, and it's called a point checker. Okay, and I'm going to check the camera, make sure you can see that. Yeah, you can kind of see it. We'll get it lined up a little bit better. And this point checker has got a little tiny needle on it. And I don't know if the camera's going to pick that up, but this little tiny needle, and we'll turn this on. And all that we need to do is we will hook one side of this to ground, and we'll hook the other side. This is our point wire. This is hooked directly to our points, and it shows that our points are open. Now, it doesn't mean that our points are clean. I just kind of did whatever, but we'll take a look at it. And that's about where our points are opening and closing here. This you can adjust it down a little bit. We'll get it to it's open, and then it's right about in there. And there's very little change in the ohmage there. If you hook this up a little bit, you could get a little bit more change, but we're just want to see when it changes over. So it's right about, let's see, there's closed, and then they open. So the timing is a bit advanced at this point. So what we need to do is we're going to go in here with a screwdriver, and there's a slotted head screw in here. And you have to loosen up that screw, and there's a little slot inside there. I'm going to get a different screwdriver that's a little bit smaller, and we'll take a look, and I'll show you that slot here. It's got a lot of magnetism on it. That's in good shape. If we look here in our points, I loosened up this screw right here, and there's a slot inside here that allows us to open and close the points a little bit. And you adjust the points that way. So you loosen up the screw, you can adjust the points, and we are going to be closing them down a little bit. So we're going to be rotating, we're just going to be forcing them this way. And once we do that, then the point, because we're a little advanced at the moment, so we need to retard the timing ever so slightly. And again, we got a lot of magnetism going on here, so it's making life a little difficult. Let me see if I can get this guy. There we go. Okay, he's on. And we go back to here. And it's a little hard for me to see at this angle, so anyway, points are closed, and then they pop open. That's all you get, just a little bit. And so what we're going to do here is we're going to get inside. And again, it's a little hard to see, but I've got it. And then I'm just going to close that down till it just close the points, tighten it down, and see how we did. And the points pop open. That's a little late, so we'll open it again, and then we'll get the screwdriver in there. The magnetism is pretty stiff. We'll open a little bit, just a little tiny bit, and it changes a little bit when you, with the screw, when you tighten down the screw, so that it causes a little bit of grief to, you have to work it a little bit, okay? And we are, that's there, and I'm looking at this, so I need to just open it just a little bit more, or we'll close it a little more, excuse me. There we go. Let's see what we got. And they pop open right there, and that's exactly on the mark. Maybe not. We just need a little bit. Check that. And that's exactly on the mark. Okay, and then we'll make sure everything's tight, which it is, and we are timed perfectly. And that's all there is to it. And all we did is we just adjusted the point gap. Again, these magnetos, that's the only way you can adjust the point, adjust the timing. So that's how a magneto ignition system works. But there's a couple other things that you might want to understand. If in a magneto ignition, yes, you have one coil that will operate the ignition system so you can get spark, but in there you see that there are other coils in there. And in most of these systems, there are three separate systems inside there. We have the ignition system, which we just talked about, but we also have a battery charging system. Now, the battery charging system is a unique character. It does not have a regulator in it. Basically, there's a coil or a set of windings around a coil, a ferrite bar, that will go on ahead and send AC pulses to a rectifier, which is just basically a diode system in there. And that diode goes out and it feeds directly into a battery. The battery itself is the regulator. So anybody who's ever dealt with these things before will find out that if you pull the battery out of one of these systems and you start it up, it blows out all your lights. It'll blow out your tail light, it'll blow out your speedometer lights, it'll blow out your neutral light. It just blows them out because the battery itself is clamping down the voltage. That's just basically what you need to know. So if you have a magneto system that will run without a battery, you need to have, if you're going to be disconnecting the battery, pull your bulbs out or do whatever, because they will blow up, because that battery is clamping down the voltage to a reasonable level. It doesn't clamp it down to exactly 6 volts. It'll be higher than that, but it holds it down to a reasonable level so your bulbs don't blow. That's one thing. Then there's also another circuit in there, and it is just for the headlight. There's a separate coil in there. Sometimes there's 3 coils, sometimes there will be 2, but the one with 2 coils, it's got 2 separate sets of windings in it, and one set of windings is to charge the battery, and the other one is to operate the headlight. And it just does nothing more than sends AC voltage out to the headlight, and that's the reason it doesn't work. Your headlight won't work without the engine running, because all it's doing is just taking that rotating magnet that's going across the coil and sending out pulses of and they're going positive and negative, because it's AC voltage, sending it out to the headlight. And the headlight at that point can then light up. And as soon as the engine dies, the headlight goes away. Those systems are very reliable. They don't require any regulation. There's no diodes. It's not changing AC to DC. It's not doing anything. It's just straight on out to the headlight. And there's the ignition switch will just turn that on and off. So it just one other position in your ignition switch is just connecting out to the headlight. So remember that there's the ignition system, which requires, and on those ignition systems, just for a little piece of information, if you have an ignition system in most bikes, you can unplug the ignition switch, just completely unplug it, and the bike will run. It will just run. But again, you have to make sure that if you have lights in one of these types of systems, and they're like this little 6-volt batteries, it has a tail light or anything like that, you need to make sure it has a battery. And if it doesn't have a battery, disconnect all the bulbs, disconnect all the wires going to the bulbs, or you just blow them up. So anyway, that's how a magneto point ignition system works. So again, thanks for watching. Don't forget to subscribe and like, and we will see you in the next one.